Hello, everyone. My name is Shachar. I'm a product manager in Google Cloud. I work on the database migration service. Thank you for joining the session. Today, we're going to talk about how to choose the right solution when migrating your databases to the cloud. So I think that by now we established why moving to the cloud, right? We see a lot of customers that want to move to the cloud. The main two reasons why customers want to actually move to the cloud is either they want to basically to free the cost of maintaining and managing like legacy proprietary databases that basically stop them from innovating and take these budgets into innovation. And then when they move to the cloud, they're able to basically free up these budgets. And in addition, we saw a lot of companies that want to scale up, right? They didn't expect that their application will scale that fast. And now with Google Cloud, or basically in cloud in general, they have services and the databases that can auto scale and write and basically accelerate with the business. So these are like the main two reasons with many others that customers want to move to the cloud. And the way that we look in Google Cloud on the type of journeys that customers has, so there are basically three types of journeys. The first type is the migrate journey. Migrate journey means that the customer has a database that he just wants to lift and shift it. Lift and shift means that they have a database outside of the cloud or on-prem, managed VM, maybe in other cloud, and they just want to move the exact same database to the cloud without doing any changes. This is what we call a lift and shift migrations. And the expectations from these migrations would be that I would get the exact same copy, as we say, into the new database that I'm moving to. This is the first part, that this is like the most simple type of journey. No migration is simple, but at least out of these three options, the migrate is the easiest one. One like use case that I can mention is, for example, I have a MySQL database that is now on-prem or is now, I don't know, in AWS, and I want to migrate it to Cloud SQL for MySQL. This would fall under the migrate journey. The second journey is the modernized journey. This is when customers want to move from like an old guard vendors into like an enterprise class compatible databases. So basically to an open source type of databases. So that means they want to take their current database and they want to change engines and move to the cloud while changing this engine. One use case is, for example, they are currently in Oracle and they want to move to Postgres, to Cloud SQL for Postgres, for example. This type of journey is like more complicated, right? Because there are a lot of alignments, and we'll touch on them in the presentation as well. The third type of journey is the transform. This is basically when you want to transform into cloud native databases. So, every cloud and in Google Cloud as well, we have like native databases, and customers are utilizing them in order to deliver like new experiences to the customers. And that basically means that during this transformation, they are able to design their business differently, they're able to design the application differently, and basically they want to do many new things that only with using those native databases, cloud native databases, they're able to do so. And this is another type of journey. In this talk, I'm going to talk mostly about the migrate and modernize, but all three types of journey are valid and what we see from customers. So why migration can be challenging? So we know that migrations are complex, right? So if any of you did migrations, and we saw like lots of customers with migration, you start when you're saying, I want to migrate this database. And then when you start like digging inside your my database in your application, you find out there are a lot of like dependencies on this database. This database is related to other databases and is related to read replicas and is related to other things. And then you need to understand what is like the impact of this basically migration on your organization. So every migration requires some kind of organization and planning. So every migration is complex. It's a time-consuming and high toll. So creating the migration, monitoring it, establishing the connectivity, making sure that everything was migrated properly is something that will take time, right? You're taking one database, or taking basically one source and moving it to the destination, and this is something that you need to allocate time to do so. And when choosing the service, and we'll touch that like later on in the presentation, you need to make sure that you're choosing the right service or the right tooling to do so. So in any way, it will be something that we need to allocate time, and it's a risky, right? And risky and complex are like attached to one each other. So you're taking a mission critical database, for example, your production database that is affecting your application, and you're moving it to a new place, and this usually means that you have some downtime, right? So any engines has different risk. In any migration, you are most likely going to change a couple of things in even if the most simple migration use cases. So migration is always risky. And when we're talking about migration, so most of migrations has like 4 steps. So all migration of databases has like these 4 steps, which are assessment, environmental setup, data migration, and migration validation. So in the assessment part is basically when you're assessing the different databases that can be best serve your use case. So you have a source database. You have like a database that you're working now. And now, first of all, you're choosing your journey, right? You're choosing if you want to move, as we call homogeneous use case, lift and shift. So MySQL to MySQL, Postgres to Postgres, and so on. And in that case, the assessment is not like a major part, right? Because you know that most things that you will do, unless there are different variation between you're now working on MySQL on your on-prem and you're moving to Cloud SQL, or you're moving from Postgres to Cloud SQL for Postgres, maybe you need to check extensions, for example. But the assessment is very short. If you're moving now from Oracle to Postgres, the assessment part or the assessment section of it will be more complicated, right? So this is the part when you're taking the source, you're taking the target that you want to migrate, and then you basically assess what are the changes that we'll need to take into consideration. The next part will be environment setup. So usually, if this is a homogeneous use case, like to like, MySQL, SQL Server, there aren't many schema changes, right? There are many like query conversions because everything should work as it worked on your like previous database. But again, if you're doing heterogeneous migrations, Oracle to Postgres, you need to change a lot. We're going to touch on that later on. But one part is that you want to make sure that you're moving to an environment that is like ready to take the new type of databases, and basically need to change quite a bit of things there in heterogeneous use cases. The third part is the data migration. The data migration is basically the part that you're moving the data, right? So there are a couple of requirements when moving the data. For example, minimal downtime, right? You don't want to have a lot of downtime when you're moving your databases from one place to another place. So you're migrating the data, and the schema. You can do a one-time migration. You can do an ongoing migration. We're going to talk about it later on, but the data migration is basically the first time when the data starts flowing one end to another one. And the fourth part is the migration validation. So after you moved, you want to make sure that the application still works, right? That the performance you expected from the new database that you chose is actually the performance that you're getting. So like any type of migration, homogeneous or heterogeneous, validation is important, and it will be a step that you will take in any use case that you will choose. So let's like dig a bit deeper inside like every step of the migration. So migration assessment. As I was saying, homogeneous DB migration will just work, right? So you have MySQL to Cloud SQL for MySQL. I'm taking like use cases from Google Cloud, of course, but MySQL to Cloud SQL for MySQL, Postgres to Cloud SQL for Postgres, SQL Server to Cloud SQL for SQL Server, Redis to Memory Store for Redis, HBase to Cloud Bigtable. So everything here is compatible, right? And you can use, for example, our new database migration service that is covering for the MySQL, Postgres, and SQL Server in order to, and we're doing that in a way that, as it says, it just works, right? You just like configuring your source, your destination, and it will just work for you. But this is the homogeneous use case. For the heterogeneous use case, so the assessment part, because you're moving, let's say, from MySQL to Cloud Spanner, right? You're moving from MySQL to Cloud Spanner because you want the scalability portion of Cloud Spanner. You want to move from Oracle to Postgres for better ROI. Let's say that you don't want to pay for the license. You're moving from Cassandra to Bigtable for manageability. So any type of migration that you will choose, like any pairing that are not like to like, are not, the same type of engines, you will still have the assessment. In the assessment, you need to understand what will be the implication. You need to plan, to plan the migration in a way that you know exactly what needs to be changed in any step of the way, or what needs to be changed before the migration, what needs to be verified after the migration. And the assessment part is maybe the most important part in the heterogeneous database migrations. And it will require like all steps of the journey. So it will require the assessment, regarding the conversion, the environment setup, and this is like the most complicated part that you will need to do. The second type is the environment setup. So as I was saying, in heterogeneous migrations, let's take Oracle to Postgres, you need to make sure that the new database that you're moving, you're converting the objects and the schema to the new type of databases. So let's say that you're moving from Oracle to Postgres. So if you have Oracle type, you need to change it to Postgres type. For example, for this use cases, you have Oracle PG that can help you doing so. But this is something that you will need to do before the migration actually starts. Another thing is query conversion, right? You have like queries that are written in one language, you need to change it to a different language. So let's say you have PLSQL or stored procedure, make sure like that the target database support this syntax, right? You don't want to move the data and then basically the migration will fail, or to identify that something doesn't work because the terminology is different, or you would have something that is not supported in Postgres that is supported in Oracle. Data migration, step 3. So now you did everything that you need to do. So assessment, you prepare your environment, everything is ready for the migration. Now we need to actually move the data. So first of all, let's decide. You need to decide if you want to have a one-time load of the migration and want to have an ongoing. One-time load, it means that basically you're taking a snapshot of your database. Okay, so you're taking the entire snapshot of the database, which represent like a single point in time, and then doing like backup and restore on the new to the new target, to the new database that you're moving to. This means that you have an application downtime which will be long, right? It will the downtime you will need to endure would be the amount of time that it takes you to take the initial dump, or the initial like backup of the database, and the time it will take you to load it. This means that this usually method is suitable for databases that are not mission critical and that can endure this downtime. So usually small databases that are not used, maybe development databases. The other type of migration is the ongoing CDC. We call it in Google, we call it continuous migration. This is like, I don't know, 99% of our customers want this type of migration for most of the databases. So in this method, so the migration like tooling still takes the initial like snapshot of the data, but it keeps tracking the changes that happens along the way. And then basically there is the initial load of the data, and then the service basically keeps taking data and keeps tracking on the changes that happens. And then we have like a figure named replication delay, which is like slowly decreasing over time until a point where the replication delay is minimal. So it's zero, almost zero. That means that both the source and the destination are in sync, right? And you can leave this migration, or leave this like replication running for a very long while, do all your tests, And basically, you don't have any downtime in this method, right? You don't have any downtime during the migration. So this is what we call a minimal or a zero downtime production cutover, which is extremely important for customers. So first part is the migration tab that you need to understand which databases you must have zero downtime, and then choose like continuous migration. If you can endure the downtime, you can choose the one time. The second thing is the migration fidelity, right? So you need to understand what's not migrated, right? So we know that like in heterogeneous migrations, there are stuff that will not be migrated because they are not compatible between the source and the target. Even for homogeneous migrations, so like to like, MySQL, Postgres, there are parts that are not 100% complete between the source and the target. So there are entities that will not be migrated. You will need to do some work post the migration in order to complete them. For example, does the service migrate users, permissions? Does the service migrate tables that, I don't know, don't have primary keys? Does the service migrate stored procedures, triggers? Does the service migrate only like data and schema and not migrating all the objects, right? Like, as I said, stored procedures, triggers. So you need to understand everything that is not migrated in order to have like full like compatibility between the source and the target. Additional thing is DDLs, right? So if you have DDL changes, so you're changing, table structure along the way, you need to understand if the service or the tools that you're using for migration supports DDL. So if the source is like DDL heavy, it might impact like the feasibility of the migration, right? There are services that don't allow DDLs. There are services that allow DDLs. You need to understand how many changes, and for time to time, you will need to just disable the DDLs during the migration, which again, I think it's like it's a requirement that does make sense, right? You're doing a migration. There is a certain time that you need to maybe stop a couple of your processes, specifically around changes. Replication mechanism. So if the tool actually expose it, so you can use either native replication mechanism, so not use, but if the services can use native replication mechanism, so MySQL dump, pglogical, transactional, whatever the native replication, that means that basically the Postgres develop pglogical, MySQL develop MySQL dump, SQL Server transactional. So this means that the service that you're using is using a native replication mechanism, which is highly reliable, right? Because we know that from a customer standpoint, they know what they're using, they know what is like operating under the hood. They're getting a high fidelity level, right? So they know that the level of completeness of the data between the source and the target is in a very high level. And it requires less validation, right? Because this is something that was developed natively. So, for example, we know that native tooling does, for example, migrate the database objects. So customers usually require less validation, right? Because they know that this is a mechanism that they know exactly what is operating. The other option is the service that you're using is a black box, meaning that you don't know what is the replication mechanism, and you don't really know how the service is doing the replication. But that also means that the underlying mechanism was built maybe to overcome like native replication limitations. Okay, so that means that maybe the duration or the throughput of the migration is like higher than if it was developed by native tooling. There are a couple of limitations in native tooling that maybe don't apply because the service that basically developed their own replication mechanism. The main thing is that it's less predictable, right? We know what is MySQL dump. We don't know what is like an underlying technology that we don't know what is the underlying technology. And it's harder to investigate, right? For MySQL dump, pglogical, all the like the native tooling, it's harder to find online answers to your question rather than locking yourself to the specific vendor that you choose for the migration to their own documentation and support. So the next thing is who owns the replication. So to clarify, there are services that as a customer you need to maintain the replication entity, the replication instance. That means that you're the one that is responsible on establishing the connectivity. You're the one that is responsible as a customer, to give the replication instance or mechanism more power or less power. So basically, the entire responsibility is in your side. There are services that they are basically serverless, right? So you don't need to maintain any replication mechanism or any replication instance. You are not in charge on that. And some services even allow support for establishing connectivity. So there are basically three questions that you need to answer when you're choosing the service. Who is in charge on establishing connectivity? Again, if you are the one that is owning the connectivity instance, so you will be the one that is in charge of establishing connectivity. If you are not, so you will always be responsible for establishing the connectivity. But if it's a serverless service, there are things that the service can do in order to make the connectivity, which from all the customers that we got, is the most point with friction. Services can find a way to ease up this by proper documentation or any scripts. Can the migration entity be scaled up? So can you give more power or less power? Who is responsible of that? Who owns the instance that is running the migration? So again, are you paying for the instance that is running the migration? Are you are you the one that is responsible for errors? Do you need to configure monitoring specifically on the replication instance rather than the migration entity? So this is another consideration. And the fourth part of the migration is the migration validation. So migration validation is after you manage, you did a good job, you managed to move all the data, now you need to basically do all the QA processes. So application QA, you need to connect the application to see that everything works as expected, the performance is properly as you expected. There weren't any changes for the new destination. Usually what we saw customers are doing, they did a lot of POCs. Okay, so they ran a lot of test migration before actually touching the production database. And this is one of the most important parts of the migration, right? Validate, run POCs, and when you feel comfortable, do an actual production migration, and then test as long as you want, right? It's continuous migration, test as long as you want the new instance to make sure that you didn't lose anything in the way. So there is a list of all the validation that you can do. I'm pretty sure that anyone that is doing migration is fully aware that they need to do a lot of validation. So after I showed you all the steps and maybe all the questions that you need to raise when you're choosing which tooling to move move your database. I want to talk about the Google Cloud Database Migration Service, which is a service that we introduced. And as I was saying, it's streamlining and making a fast track to your migration of MySQL, Postgres, SQL Server to Cloud SQL with minimal downtime, right? Most of customers of even 99.9% of them want minimal downtime, and this is what DMS is supporting. So the way that we build it, and again, it connects to the entire topic that I mentioned before that, is that we build DMS in a way that it's simple. So we wanted to build a service that is predictable, right? So customers can see what is part of the migration preparation. So what they need to configure, what are the prerequisites. Everything is part of the product. So all the documentation, or 99% of the documentation, is part of the product. So when you work on DMS, you can know exactly what you need to do in every step of the way. We have a guided secure connectivity setup. So we're helping you with establishing connectivity. It's still a process that you need to do mostly by yourself, but we are providing docs to exactly how to do so, and in some cases we're even providing scripts that you can run in order to establish connectivity. One, like the most important thing that we did is that we saw that in other services or in other like migration tooling, you fail late in the process rather than testing it very early, understand what was not configured correctly. So with DMS, you can test all the configuration you did before actually starting the migration. So this is the validation. So you can test it. I will show you like a quick demo after that, and make sure the configuration was configured correctly. The next part is the DMS is serverless. You don't need to maintain any replication instance. You are not in charge on this part. So we are providing continuous replication. Again, fast cutover, minimal downtime. You are fully aware of what is the replication delay. If there is a replication delay, you can decide whenever you want to do the cutover or the promotion. You don't have any servers to deploy or any resources to manage, and the migration auto scales with the speed of your data, right? So when I mentioned if the service is who is responsible of the replication instance, so in DMS it's serverless. We are the one, DMS are the ones that are responsible on that, and in addition, it's compatible and secure. So we are utilizing, and again, this is for the homogeneous use cases, MySQL, Postgres, SQL Server, SQL Server. We are utilizing a native replication. So I'm utilizing MySQL dump, PG Logical, which provide us like higher fidelity and greater reliability, right? So again, it's all part of the predictability. You know what you're using. We are utilizing the native replication. You need less validation. And we are supporting multiple secure connectivity methods. So you can migrate on top of public connectivity, so on top of public IP, and you can migrate on top of private connectivity. So VPC peering, VPN, tunnel, whatever you want, you can use DMS in order to do so. And our documentation and our experience as part of the products helps you to do that in a way that you will be successful early than late. One more thing is that DMS for the homogeneous use cases doesn't have any additional cost, right? You're paying for the instance you're creating, the Cloud SQL instance you're creating, and that's it. So it comes with no additional cost. Let's go to the DMS demo. So we just stop that for a second. So I'm going to show you like a quick demo. So this is DMS. The first thing that you will do, you will create a migration job, okay? Just maybe see if I can. Yeah, no, I think it's fine. Okay, so you're choosing what is the name of the migration. You're choosing a job ID, which is auto assigned to you based on the name. You're choosing the type of the migration, so MySQL, Postgres, Cloud SQL, RDS. You're choosing which type of the migration do you want, and based on those decisions, you have all the prerequisites, all the in product documentation that you can basically see what are the prerequisites that are required in order to run the migration, which is extremely important. So this is exactly the part when we said that DMS is highly predictable, and you can basically view the documentation ahead of time, right? The next part is to save the configuration. You can save and exit in any step of the way in order not to lose your progress. For example, now you reach to a part that that requires some network, the network guy or your girl from your team to help you with the connectivity. You can save and exit and go back to that later. The next part is defining your source. So you can choose to create a new one, which we call a connection profile, which basically represents your source. And then basically on that source, you can either create it before that, or you can create it now. You're basically assigning a host name, user, password, and that's it. Now that you have the source, you're now ready to create the new Cloud SQL instance. So if you ever created the Cloud SQL instance, this would seem, extremely, it would seem extremely familiar. We're basically doing the same thing. You're creating the SQL instance as part of the migration creation. You're choosing onto which instance you want to migrate. You're choosing if you want to do it on private IP, on public IP. How do you want to migrate on top of which type of connectivity? Choosing the machine type, choosing the storage type. Of course, that you can choose to auto increase the storage. So if the migration, the instance will grow with your data. And then you're choosing the connectivity. So you can choose public IP connectivity, private IP connectivity. You have IP allow list, reverse SSH, VPC peering. So whatever the way that you want to migrate, you can do it using DMS. And let's skip. So we chose VPC peering, and now this is exactly the step that that is where you can test your job, right? You can test the configurations that you did and make sure that everything worked as expected. So if there were any errors during the configuration, you will see them now rather than failing late. We're running the test, everything was successful, and then you can choose to create the migration, and you can choose to create and start it. Create the migration means that you will create the migration job, and then you will start it later, and you can create and start, which means that it will start immediately. And that's it. Now you're creating and starting your migration. You have a way to see basically what is the start of the migration. Is it now in full dump, in the initial dump? Is it now in CDC? What is the replication delay? How much data was moved? What is the storage usage? And then in a certain point, you can see what is the replication delay, and you can choose to promote. Promote means that this is no longer a replica. This is now a standalone instance, and that's it. So this is the demo of DMS. Let me just... Okay, so final tips that I have for anyone that will do migration, and specifically for choosing the service that you want to choose. First of all, not every type of migration should be handled by the same service, but the same type of service. So match the right migration type to the right database and the right service. For example, for any case that you can endure downtime, you can do dump and load. You can do the one-time migration, and that would basically be suitable to you, right? You choose to do that. It will be faster rather than creating a migration. And make sure that you know exactly which databases are you migrating, exactly which migration type you want to use. Second of all, read the docs, okay? Specifically, go to the limitation steps, to the limitation section, and to the fidelity section to know exactly what's not migrated, what is migrated. Are there any limitations that I need to take into consideration? Read the docs. Migrations are a risky business, and you need to treat it as such. So make sure to read the docs. As you see in DMS, the documentation is part of the product. Run as many POCs as possible. So run a test migration, run another test migration, try to run as many as you can, and try to run it with databases that are similar to the one that you're planning to migrate. And of course, monitor your migration. So make sure that you are fully aware of what is the migration status, how much data was migrated, what is the replication delay, any type of information that the service exposed to you, make sure that you monitor it. And that's it. So if you have any questions about database migrations, you can contact me directly at thegoose@google.com. And if you have any other question, you can contact me directly. And that's it. I hope that you learned a thing or two. And thank you.